Hi there, this is our third episode on writing a REST API with Go. And this time, we're going to talk about concurrency. And this is a topic where Go shines because Go has Go routines and channels. And we're going to use both in this episode. A Go routine is basically another thread of execution. And a channel is a synchronization primitive. You write to a channel and you have to wait until somebody reads from it. You read from a channel, and if there's no data there, you have to wait for it until somebody writes to it. So basically, it is a way to synchronizing two threads that are running on your system. Let's see how to use them in order to write a graceful shutdown for our HTTP server.
Let's start by refactoring the code that we wrote for our last episode. In this case, we are registering the handlers, the functions that provide the response for the request to the HTTP server in these two lines, in line 43 and line 46. What we want to do is, instead of using http.handlefunc, which is provided by the standard library and uses the default mux, we are going to create our own router. And we're going to do that here, defining the router like this. We use also a function of the standard library, create a new server multiplexer, and then we register the to handle to this router as we were doing before. Now that we have that, we can get rid of these lines that we're doing basically the same with the default multiplexer. The next thing that we want to do is to create an instance of HTTP serve. And this is done, this HTTP server is populated with the data that we have defined before. So here I'm using the server address that I defined before as a constant, and I'm using the router, the multiplexer that I have just created right before. This server is what we're going to use instead of the default multiplexer. That is what the http.listen.serve uses. So we're going to have another line here that is going to be very similar to this one. The main difference is that it uses this server instance that I have created, and it doesn't need to have the server address or the nil here. The server address is contained here, and nil meant that I was using the default multiplexer. But here I don't want to use the default, I use this router here. So I can get rid of this line too, because it has been replaced. And now that I have this stored, I can go and run this code. I can go to the run and debug, and I click on the play button, and hopefully I will have this running right away. And I get the Hola Caracola in the console, and this orange color shows me that everything is running. So I go to the terminal here, and I use the same command that I was using in the previous episode to make a query to the HTTP server. And when I run it, I get exactly the same response. Our goal is to shut down our server properly. So we don't want an error to be printed when we close the HTTP server willingly. And this statement here says that I'm going to print the error even when that is the case. So I'm going to change this statement, and I'm going to use this other one instead that says getting the error from listen and serve. And if the error is not server close, which is what happens when I shut down the server properly, that is going to print an error. But if it is server close, then I don't print anything. So I'm going to format this properly, and I'm going to get rid of the previous statement that I have here. With this in place, I would like to register the function that I need to execute when the server is shut down. And how do I do that? Well, I use the same server type that I had created before, and I use this function, which is register and shutdown, and I'm going to use a lambda here that is going to be executed when the server is shut down properly. So here, I'm not doing much. I'm just printing signal shutdown, but you can put here any code you wish. In our case, we were creating a connection to the MongoDB Atlas database, and we are using a defer function to ensure that when the main function finishes, the MongoDB client will be disconnected from the database. But here in this shutdown function, you can run any other things, or you can move that disconnection to this part of the server. Whatever you want to do here, the important thing is that this code gets executed, but we need a way to stop the server. So here, I'm going to create a function that is going to contain the code that will be listening for the signal, the Control-C, that tells the server to shut down. I'm going to create a channel that is going to be of type OS signal, and it has a buffer of size 1. That is a requirement of this notify function. Then I use the signal package and this notify function with this channel that I have just created, and I tell it to listen to OS interrupt, that means Control-C, signals. So what this will do is that when the user uses Control-C on the terminal that is running the HTTP server, it will write to this sigint channel. So here I'm going to wait for this to happen by reading from this channel. Now here I have waited for any thing to write to the channel, which is only the notify function. When this happens, I want to shut down the server properly, the HTTP server. And I do that by using server.shutdown. I use the context background. And if there is an error here, I'm going to print it to the screen. I want this to happen concurrently. I want this to wait for the signal while I'm listening and serving HTTP connections. So I need to use a go routine here instead of just a function declaration. I'm going to do that here. And this needs to be an invocation because this is a statement. So here I'm going to use the parenthesis to mean run this as a go routine. Okay, so far so good. We will be writing to the sigint when the Control-C signal is received. But the truth is that we are not able to ensure that whatever code is contained in this shutdown function finishes before we exit the main function. When we exit the main function, any go routines that are running at that moment, and this shutdown function is executed as a go routine, are closed. So how do we ensure that no matter how long this gets executed till the end? Well, what we can do is to use another channel to synchronize that. We're going to define this channel here at the beginning of our application. Right before defining this context, I'm going to create a new channel, and that is going to be this one. This channel, which I have called done, is a channel of empty struct, which means I don't need any data. I just need the signal. I just need the synchronization that I can create with this channel. With this channel in place, I will wait to exit main for this channel to have data. So here I'm going to read from done, and I won't exit the main function until this is written. And where do I have to write this? Well, since I want to wait for this function, this Lambda function, to finish, what I'm going to do is to create a defer block here, which is going to write to this done channel. Notice that here, what I'm doing is basically writing an empty instance of the struct. So no data, but just saying, hey, we're done. And we run this in a defer block. So once this Lambda is finished, we will write to the done channel. And only then we will exit the main function. That's pretty easy. So what we could do in order to test that is to have this function take a little bit longer. So we're going to add some 5 seconds here. I'll wait for these 5 seconds. And once these 5 seconds have happened, then we will be writing to the done channel, and hopefully we will exit the main function and we have done a graceful shutdown. So let's try this. Let's go to the terminal, and here I'm going to run the code of this application, and we get the Hola Caracola, which means that now it's running. And if I type Control C, it gets the signal shutdown, waits for 5 seconds, and exits. Wow, ain't that cool? So yes, we got exactly what we were looking for. There is one more caveat though. If I run this program here in a terminal, then I'm using the port that I have defined in the constant. If I run a second terminal here and run the program again, that will cause it, the second one, to fail because that port is in use. But that is panicking, so the final execution is not done properly. I want the program to run to the end. So let's go back to the code. And here, instead of exiting with OS exit 1, which is what Fatal does, I would like to use a print statement. So let's replace this here. And instead of using log Fatal, I'm going to use fmt printf to the standard error, the same error that I was getting before. The problem is that if I do this now, then coming back to the terminal, let me try to run this again. I will get this waiting forever because yes, the error has happened, but if I go back to the code, it is waiting for this channel to be written to. So there's nobody writing to this channel because this signal hasn't been received and there hasn't been any shutdown. Another thing that I could do is, if I have an error, and when I have an error here, I can close the channel. So I can type close done here. So reading from a closed channel doesn't cause any waiting. So by closing the channel here, we can get the code to ignore this read done because there is no channel open there. So it goes to the next line. In this case, it finishes with the program. So let's go to the terminal. Let's try this. Let's close this part, and 1, 2, 3, 4, 5. We'll run it again, and hopefully now we will get the error and it will exit immediately.
In this episode, we have learned how to use Go routines and channels to do a graceful shutdown, and learn how to combine them in order to get the desired effect. It is not a trivial implementation, although what we did was pretty easy, but it requires to pay extreme attention to details. Still, I hope that the explanation was clear. Feel free to ask any questions in the comments. And if you're interested in having more content on Go, share it there and we will plan for some more. Meanwhile, stay curious, hack your code. See you next time.